Hello and welcome. We're going to solve this problem together, but why don't you take a moment, pause the video, and read it on your own. Okay, so let's read the question. If triangle ABC, so we'll define it, okay, here's our triangle A and B and C, is rotated 90 degrees clockwise about the origin, what will be the new coordinates of vertex B? All right, so what does this mean? So first of all, a vertex is a point where two lines meet on a polygon, or a triangle in this case. So that's our vertex, and it's at B. I'm just going to write down where it is right now. So I know that B is at, here's the origin, go back 4 and up 1. So B is just the point, right? I'm just going to label it here, sorry. B is the point -4, 1. Now we want to find out if we rotate this shape around the origin, where will the new coordinates of vertex B be located? All right, so first of all, one way to think about rotating this thing around the origin is to imagine that this is our origin, 0, 0. Imagine like there's a pin in your paper and you're spinning, right, the whole graph around this pin in a circular motion clockwise this way. If we do that 90 degrees, you can start to imagine that the triangle is going to end up somewhere over here in this quadrant, right? So to understand the answer then, what we need to think about is how do we measure the 90 degrees? 90 degrees, like there's an angle, a 90 degree angle is between two lines. Where are those lines? Well, what you would do next is then just take your ruler and draw a line from B to the origin. Oops, and I'm going to use red to be color coded here because I drew B in red. So that's our line to the origin. So essentially this is our starting point. We now turn, now it's kind of like a rope, right, connected to the origin. The origin's we're pinning this rope down at the origin. It's going to point B, and then we're turning, like keeping the rope as tight as possible, turning it 90 degrees this way. And we're going to keep turning it until our new line is at a 90 degree angle to the original. So let's do that. Let's turn, you know. You can start to estimate. You know, we haven't reached 90 degrees yet. We have to find that L shape. It's not there. And then it's not here, right? Where is it, right? Think about where it's going to be, that 90 degree angle. Also, I can't extend this line longer. It can't be further from the origin. The rope has to be the same distance. And that distance is over 4 and up 1 from the origin. Right? Notice I'm describing that distance as how far over I have to go and how far up. So if you look at our choices down here, the only one that really satisfies what we need is this point right here, the point 1,4. And if I draw it, you might be able to see, oh yeah, look at that. We've got this new point up here. The angle between these two lines here is now 90 degrees. That's where the 90 degrees shows up, right? And again, I've gone now, instead of back 4 and up 1, I've gone up 4 and over 1. It's the same distance. Imagine you're kind of walking, you know, you're here at the origin, you're walking up a street 4 blocks and over 1 block. That's the same as going over 4 blocks this way and then over 1, right? It's the same distance, and that's 90 degrees. So our answer, of course, is then 1,4. The point 1,4, choice B. So let's just look at the other points to get a sense of why why we know they're incorrect. So first of all, A. A is -1, -4, this point here, right? So this point, -1, -4, that's a rotation, but it's not clockwise, it's counterclockwise. Oops. So if we look at this rotation, we start again here and then turn it this way. Now we get 90 degrees, oops, but it's in the other direction, right? So it's down here. And that's 90 degrees, of course, but it's counterclockwise, CC. We want clockwise here, right? So we're going this way, so that one doesn't work. And then C is 4, 1, that's the point here. Let's look at that. So that, right, brings us quite further, right? We have here, we go swing 90 degrees, and then over here. At this angle, it's much larger, right? It's not a full 180 degrees, but it's certainly more than 90 degrees, right? 180 is a straight line between these two. We'll form a perfectly straight line, which we get in choice D, actually. D is the point 4, -1, and that's a 180 degree rotation. Let's just see what that looks like. We go swinging around, and all the way here, right? So that is, oh boy, badly drawn by me. This is 180 degrees, and you can tell because it forms a complete line between these two. It's 180 degrees, and that's not what we're looking for. We're looking for 90 degrees. All right, I hope this helped.